Hello everyone, welcome to Digital Communication Tutorials. In this video, I am going to take up the fourth numerical on detection and estimation. Please note this is a numerical on the matched filter receiver. Let me read out the question first. Figure below shows a finite energy signal phi of t. Part A of the question says, sketch the impulse response H optimum of t of the optimum filter matched to phi of t. Part B of the numerical says, determine the value of the output of the matched filter at t equals to capital T, assuming noise is 0 and input is phi of t. Look at the numerical here. Phi of t is a rectangular function of duration capital T and amplitude A. Let us start with the solution part. In the numerical, the part 1 of the question says, sketch the impulse response H optimum of t of the optimum filter matched to the given signal phi of t. I have previously discussed the matched filter receivers in one of my previous videos. If you have not yet watched that video, I highly recommend you to watch that video. You can click on the link shown in the top right corner right now, or I will leave the link of the same in the video description below. From the topic of matched filter receiver, we know the impulse response H optimum of t of an optimum filter matched to phi of t is given by the expression. It's given as H optimum of t is equal to phi of capital T minus small t. Let me call it as equation 1. Please note, in the numerical we are given the value of phi of t. So let me now plot the H optimum of t. I will do it in two separate parts. First I will plot phi of minus t and then I will introduce the delay term capital T. Right. So this is phi of minus t. So the phi of capital T minus t can be now given as, here I have to simply shift phi of minus t to the right by a value of capital T. So this reduces to, right, this is the impulse response of the optimum filter matched to phi of t. Comparing the diagrams for phi of t and phi of capital T minus small t, we find that they are one and the same. Right, that is the end of part A of the numerical. Let me now move on to part B. The part B of the numerical says, determine the value of the output of the matched filter at t is equals to capital T, assuming noise is 0 and the input to the filter is phi of t. Let us start with that part here. We are told the noise at the input of the matched filter is 0. Also, it is given in the numerical that the input to this filter is nothing but phi of t. Right. So, we have previously established in the theory that a correlator and a matched filter produces identical output at time t is equals to capital T. Therefore, I can now write the output of the filter at t is equals to capital T as, it is integral 0 to capital T x of tau into phi of tau d tau. Right. So this reduces to integral 0 to capital T x of tau, which is the input to the filter, is nothing but phi of t. So I can write this as phi of tau into phi of tau itself into d tau. Please note, the value of phi of tau here what I have taken is usually H optimum of t. But we have previously established that H optimum of t is equal to phi of capital T minus small t, which is equal to phi of t itself. So instead of writing phi of capital T minus small t, I have directly written it as phi of tau. So this expression now reduces to integral 0 to capital T phi square of tau d tau, which is nothing but the energy of the signal phi of t. So I can now say y of t at t is equals to capital T is equal to the energy of the signal phi of t. Right, let me now compute y of t. So y of t is equals to integral 0 to capital T phi square of tau into dt. This is equal to integral 0 to capital T. The value of the given signal is a over the interval 0 to capital T. So therefore it will be a square dt, which reduces to a square capital T. This is the answer for the part B of the numerical. Right. So with that, we have completed this numerical. In the first part of the numerical, please note, we were asked to sketch the optimum response of the filter, which is h optimum of t given by phi of t minus small t. And then we were asked to find the value of the output of the optimum filter at t is equals to capital T, which we found out is equal to the energy of the input of the filter, and the answer for the energy of the input signal is equal to a square t. That completes the numerical. Well, if you like this video, kindly like and share this video and subscribe to my channel for more information on digital communication. Thank you for watching. Have a good day.